Okay, so anyway, the topic of today will be on the requirements and system modeling. You'll be, after we learn this topic together, I believe you'll be able to apply what we learn into your project doing as well, okay? So you already, I would assume you already acquired certain requirements, okay? Have a chance to meet or discuss with the client for the system requirements. Then you need to really do a proper modeling of the requirements you have. And so what we will be focusing and looking at would be an object-oriented approach of the system and requirement modeling. And some recap that I will just skip because we talk about this, and then this is the RUP, Rational Unified Process. Some of them, as we discussed, there are quite a number of software process models that you can choose, right? The waterfall, the evolution, the iteration approach, the agile approach, and so on. So which process model you'll be applying, it really depends, right? On the team, on the system requirements, on the client, and very many factors. And of course, there could be, as we discussed, no single solution that you need to just apply this process model for everything. It will work for everything perfectly, no, right? It will really depend on those factors I already explained. So this is just an example of during certain period, RUP has been very popular way of doing the software engineering, but also it requires a lot of documentation too. And you can selectively use some and implement and how to say, integrate and combine and make one of your own way, the team, the agile team as well. Actually, with agile, there is no fixed process, procedure, and ceremony, and so on. It is very adaptive and dynamic according to the whole team. So if you talk to agile team in one company, agile team in another company, and your own agile team, things could be different too. The way you would decide to use, how you do the things together, at what level you will do this, a lot or less, and something like that. Okay. Anyway, I focus on some important points. Okay, here. This is example of the iterative development based on what we call Rational Unified Process, RUP. And one key thing here is that it is an iterative approach, meaning that in this RUP, we call business value. Actually, we call that. Actually, we are delivering value, right? In our term, we are delivering a software, of course, a system, of course. But this system is just nothing if it does not bring value to the business. So that is why, actually, instead of just saying that we deliver a system, it could be better to set your mindset that you are delivering a value, business value. So business value in this sense of many of the iterative development approach means that we want to deliver business value in an incrementally time-box process. And when we say time-box, remember in our Scrum, we talked last week. Of course, we have Agile. We have Agile. We have Scrum as one way of doing Agile. And inside Scrum, you have a time box concept, which is called sprint. Okay, we do a short sprint. Usually it should be a short time box. It could be from 1 to 4 weeks, or even a little bit longer. Some company team may use it 6-7 weeks, but should not be too long. Okay. And it is an iterative. Remember, it's an iterative of the sprints that you have. Once you finish one sprint, you start over another sprint, right? But you do similar way. Okay. It is adaptive to the problems, to the needs, to the requirements. Whenever there are, remember Agile, one thing, it welcomes changes. We welcome changes because actually we don't fix ourselves into a contract, right? Contract means customers say we need to do this, but later on customer change their mind or their need or understand things better. So we welcome change rather than fix ourselves with the first thing customers say to us. Okay, so that is an adaptive way. So even at the beginning, remember I asked, we discussed that we want also you to make product backlog. Product backlog can change as well, right? But not entirely, right? But something could, you understand something clearly and better, you may change or modify something too. Okay. All right. So don't forget that time box should be short and it should be a fixed period that is the same every time box. For example, you agree to have a time box of 2 weeks, then every sprint it should be 2 weeks, okay? Not like this time 2 weeks, next time, okay, let's try 3 weeks, let's try 4 weeks. Some of the adjustment is fine as long as you're stable. Once you're stable, fix with that, okay? Find the most stable time boxing period. Okay, this is just some other approaches. Okay, I will not go into the detail. It's actually what we already discussed, but okay, a little bit. So this RUP, I think we already discussed, right? This is the time boxing period of, oops. This is supposed to be the same. Actually, it should be good that if actually each of these, conceptually, they must have the same time box period, okay? Meaning that if this is 3 weeks, then every of these span are just 3 weeks, and so on, okay? And that means we move from the time move from left to right, usually most of the time. So in this RUP process, as example, we start from inception. Inside the inception, what did we do? Okay, and you could see that this is the weight, right? It defines how much of the activities that are done in each of these phases. Okay, and if it is like in the inception, of course, we would perform most of the tasks in the business modeling, understanding requirements, analysis, and design is a little, but things will be done in different, I mean, the focus are different in each of the phase of the process, the entire process. And, okay, then these are examples of sometimes if it is in the software engineering terms. The deliverable, the output, there could be many terms, right? But and one special term you might have seen in many books and articles would be artifacts. So the artifacts that are outputs kind of in different phase. But as I mentioned, this is just example. and guideline for certain process model. It's not like you must do this for every project. Okay, so example of artifacts that we produce, the team produced in the inception period phase could be vision document, initial use case model, the project plan, some or several prototypes. During the elaboration, we should have clearer idea and understanding. So use case model of the 80% completeness could be there, and also non-functional requirements, also detail of the development plan, software architecture, draft of the data model design, test cases, and so on, and so on and so on. Okay. Anyway, this is, as I said, our example, and these are more details, okay, of things that are there. And okay, some of the, yes, as I said, artifacts could happen. Where could this? Where could we expect some of this? For example, the domain model. Usually, we would expect to have it available or produced during the elaboration phase. When you understand more of the requirement and system that you are developing, you would be able to model the domain model. Actually, what is it? This will be what we will learn together, which is class diagram. Okay, we could have use case model. Note this initial as well. S for a start, R for a refinement. Okay. So anything else? We will look into this domain model for sure. Use case we already did. Some of the design, some of the test model development case. Most of these major artifacts, we will discuss them, okay, so that you are aware of those artifacts and be able to choose and use them properly. Okay, and these artifacts that I mentioned, many of them belong to or are defined, have been defined as part of what is called Unified Modeling Language, UML. And what is the UML? Anyone learned UML before? Yes? One, two, a little bit. And the rest that doesn't show hand, who don't show hand, you never learned UML in your previous study? No? Okay. Okay. That's a surprise because actually UML is a very standard modeling language used a lot in software engineering. Okay, even it has been introduced, developed, and used for many years already, but it's still becoming, it's still popularly used to represent several aspects of a system, a design, a requirement as well. Okay, so what it is? It stands for, of course, Unified Modeling Language. It's kind of standard diagramming notation. It is used and based on the object-oriented approach. So everything in UML is object-oriented. It is a rich language. It can be used to model several aspects of a system, of a software system. It contains 14 diagram types, meaning that there are a number of diagram. There are a number of diagram notation that we can choose and use. And it can be used from the, as I said, requirement modeling, system modeling, design, and so on, and even the component and architecture of the system. We will learn only some, not the 14 diagrams, because there are, it touches every possible aspect, but we may not need them all. in most of the cases. So we will discuss only major ones. Okay, now the focus of this lecture is on system modeling, which means that we are we're in the process of the system modeling means it is a process of developing abstract models of system. And actually, for a system, there could be several views you view it. For example, from user and usage point of view, you may think of use case diagram. For data point of view or domain data and domain knowledge of the system, you may think of class diagram. And the process of behavior, the aspects of behavior, we may use sequence diagram. The flow, how things work, we will use, for example, activity diagram. So there are several aspects that we could model our system. And okay, we will use UML. Why do we need it? Because with these several aspects, when you understand, obtain requirements from the users, and of course, based on these requirements, we may need to model how our system would work. And then later on, make proper design, right? By the development team will make the design and then do development as well. Then in that case, you need to represent these aspects properly, either to communicate with the user, also to communicate within the development team ourselves, and to make ourselves understanding the same thing as well. Ourselves mean the whole team. And to do some proper documentation of the system for future maintenance too. Okay. Understand functionality, communicate with the users. These are what we already mentioned. So there are several perspectives, as I mentioned. The context model, interaction model, structural model, and behavioral model. These are based on what I already mentioned. Okay, we will look into each of these perspectives later on, but look at this, the kind of classification of the 14 UML diagram types. We can divide into two broad categories of structure and behavior. And then under the structure, okay, structure of the system, this is still under the system perspective, system modeling, right? Under the structure, we would have something like class diagram, component diagram, object diagram, and many more, okay? Under the behavior of the system, we will have activity diagram, state machine, use case diagram, and interaction diagram, explaining how components, objects, or classes within the system interact with each other. And there can be several other subtypes or diagrams that we can divide further into things like communication, interaction, sequence diagram, and timing diagram. So anyway, what we will learn, we will focus only some. Definitely under the behavioral diagram, we already discussed and learned about use case model, right? Use case diagram. We will learn more on activity diagram, also sequence diagram. So actually they are still under the behavior, right? Sequence diagram is under interaction. So we will see how things interact. As part of structure diagram, the very important and must-have diagram, must learn, will be class diagram. So this will be major diagrams we learn in the class. That means if we count, number 1, use case we already studied. Number 2, we'll do today. Number 2 and number 3, I think we can do today, and also number 4, depending on the time. So these will be 4 major diagrams we learned. Okay. These already explained. Activity diagrams we will see. It is a diagram that is used for modeling the activities of a certain process. So your system, your software will need to perform certain, will need to do some task. Okay, we can call a process as well. And then activity diagram allow us to model how this task would be defined. Okay, what data would be processed, what activity will be done, and so on, and by which stakeholders. Sometimes we may involve people, sometimes we're talking only about the system components, but in activity diagram, it's more or less on the process flow, I will say. It's more of modeling business process flow. In sequence diagram, it is very much related with use case diagram, in which we will model interaction. It's part of the interaction diagram, right? In the previous categorization. So it can be used to model the interactions between actors and also our system, the actor and the system. In use case, use case diagram does not show the detail of the interaction. It just says that actor, student, perform the use case register. Actor, instructor may perform other use cases and so on, right? But it doesn't have the detail of the interaction. But in sequence diagram, we will model these interactions. Class diagram. Actually, if you learn object orientation before, the object-oriented paradigm and so on, right? If you write programs such as Java program or any other languages that are under the object-oriented programming paradigm, I think you need to already learn class diagram. Otherwise, you cannot model objects in those programs properly. So this is part of, sometimes it's called domain model. It is used to model the classes of the system, the association they have with each other. Actually, it's the same as relations, but in object-oriented world, we use the word associations, not relation. But I would say they mean the same thing anyway. So how classes, what are the classes and what are their relations or associations, as well as their behavior and so on. We will not learn state diagram, but this is part of another major UML model that you might use. Okay, it is used for showing system react to internal and external events. Okay, that's overall of the UML stuff. When you make a diagram, right, you need a tool. You are not drawing everything by hand, because then digital version of things you draw cannot be easily communicated, right? You may need proper tools. These are available tools, but as of now, there are even more and more. Okay, so don't limit to just these tools, they are just examples. So I want you to find current up-to-date tools that could be useful. It could be draw.io or those kind of things as well. But in the past, actually, there are tools which is called case tool, right? It gives some kind of help for you to draw and even relate or manage the whole diagram project together. Because many of the diagrams have certain connections. When you draw model class diagram, you define that we do have these classes. Those classes have to be constrained and be used in other diagrams. So it maintains consistency among many diagrams. That is why some of the sophisticated tools would provide you with consistency checking among diagrams. But if it is just simple tool drawing, they're just drawing, right? Whether diagram logic, whether consistency among diagrams are maintained or not, is up to you, not assisted by the tool. So some of the tools do this assistant. Okay. All right. And okay, let's now talk about the first diagram, continuing from use case. Someone said something. Miro. That is another tool or what? What is that, Son, that you type in the chat? Uh-huh. Okay. So the first diagram here of today will be on sequence diagrams. As we already discussed, sequence diagram is used for modeling interactions between actors and objects within the system. So recall, we will recall the use case diagram later on. It shows the sequence of interactions that take place during a particular use case action, okay, execution. Okay, okay. This is how sequence diagram would look like. And okay, we back to this first. The relationship, as I said, many of these UML 14 diagrams inside the UML, they are related. They are not like independent. When we say the very first diagram and model you will make when you capture and understand system requirements, user requirements, would be use case. The very first thing you model is use case diagram. Whether you draw a diagram alone, remember we used to mention as well that we need use case document, because diagram alone is an overview, overall picture, right? It says what certain actor would do to the system, right? So there could be an actor. Back to your project, we would talk about patient. We would talk about doctor. We may have other actors and so on too, right? But patient would do maybe make appointments. Doctor would do diagnose and so on, right? This is just example. It may not be the correct use case for your project. I'm just making up something based on what I understood. Anyway, so you may need to elaborate, right? Remember when you make use case document, or when we learn about use case documents, such as the make appointment, you need to have a document elaborating, explaining how make appointment would work, right? What is the main actor? Successful execution of the use case, what would be the steps? And what are the trigger or things that would happen and so on. Remember, we talked about that thing. We discussed about that. So this is what you start with. Then another diagram you might have started after the use case would be sequence diagram. And usually sequence diagram, but as I said, if you ask the software engineer, those who kind of artifact lovers, you produce tons of documentation in which I'm not supporting. So we use sequence diagram for we could use only for main success scenario within a use case or of a use case only. So usually one use case, remember one use case is just this one oval, will become or will have one sequence diagram, corresponding sequence diagram. But remember, in a use case, you may have main success scenario, you would also have certain exceptions, right? And there can be a lot of exceptions, because things could deviate to the main scenario in many variety ways. So the suggestion, best practices would be we capture mostly main success scenario plus some important exceptions, but not everything, because otherwise your diagram will be very lengthy and you will also spend a lot of time. So actually, what is the best balance? You decide. As you understand the requirement, you may need to capture the core of the requirement, the important points of the requirement. Something that is very trivial, you can ignore. Not ignore in the sense that you don't care, but you may not need to document everything. That is what I would say. You document only the core and most important parts. Okay, frequent or complex alternative scenarios. This is the exception part and alternative part. Okay, so this diagram shown here is called system sequence diagram. SSD is not just sequence diagram, but system sequence diagram with this word system. And it defines, as we said, interaction. This diagram is part of the interaction diagram, right? So you could see the interaction. What does it do? We're talking about the system and then an actor. And this is for the use case process cell. So there must be a diagram with the cashier actor with the use case process cell. Meaning that, what does it do? A customer may come with a trolley, I believe this is for a shopping in a supermarket, let's say, okay, in a shop, in a supermarket. So customer come with products they want to buy. Cashier will need to do the process sale for those products that customer wants to buy, right? So here, the use case would look like this, part of the use case. Then this sequence diagram just model the interaction of how cashier would interact with the system, the point of sale system for the process sale use case. So at the beginning, the cashier would do something, and that send an input command, a command to the system to trigger of making new sale, right? We just click that, okay, now we want to record a new sale of a customer, and then start to enter item ID and quantity. Of course, enter item ID could be through the barcode reader, doesn't need to type in the ID, right? But this is how the command or communication sent to the system. The real communication would be that this is in a form of method or function call. If you look at this notation, right, you could see that all of this, they are like function call or method call in programming, because then that makes develop converting this into programs easily. Okay, and then it is easy to say as well that with make new sale, you don't give any argument to the method. With enter item, you need 2 arguments, right? For each item, we want to record a sale. We need to know what is the product item, ID, how many quantity the customer buy. Then this is in this direction, you could see that it has the arrow, right, from cashier to the system. That means the communication is made by sending this method call from cashier to the system, of course, through certain UI of the system. And another communication method call. Then on the way back, what does it mean? This is kind of sending communication of the message communication. So the system return total and description back to the cashier, kind of output showing. And then this is iterating, this say more item, this iterate. Depending on how many products a user, a customer buys, right? It iterates like 5 products or something. Then when everything finished, a method end sale would be called by the cashier to the system, clicking finish the record, right? Meaning that the system should return total sales amount to the cashier so that we can cash money from customer. Then we record that the payment is made properly, entering amount of the payment. Of course, nowadays, with all this calculation, cashier may not even be able to calculate the change or things easily, right? If you used to work as a cashier, you will see that even sometimes it say that 20 banknotes, 10 baht coin and 2 baht coin or something has to be given as change. Sometimes, I mean, just to prevent mistake of the cashier to make change. Okay, anyway, so the system say how much change the cashier should give to the customer, and print the receipt, something like that. Okay. All right. So this is the sequence diagram. So it shows the interaction that an actor would need to interact with the system by message communication. And certain, of course, diagram have, this is the detail. And actually, I call this system sequence diagram because it shows only actor and system interaction. What is inside the system is a black box. Actually, inside a system, when you really develop a real program, you will have many other classes and programs, right? Actually, not only just the system. So inside the system itself, if we look into it as a white box, we will use sequence diagram as a white box, but system sequence diagram is just to show interaction as a black box between actor and system, and all this communication through message passing. And if you actually refer back to your use case document or use case description we used to make, these will be very corresponding. Customer arrive, cashier start a new sale. This is this one. Cashier enters item identifier, and then usually also the quantity. Then the system records and return this and that, and so on. These actually are very corresponding from what you already know, described in the use case diagram, use case document, and use case description, and then the sequence diagram. But there are conversion, right? This is more of the development oriented, developer oriented. This is more on the end user oriented, right? This way. But they are very corresponding, these two sides, from the use case and from the system sequence diagram. Okay. So element, component that you saw in the sequence diagram, we need objects, lifeline, messages. What are they? These are objects. Actors are also objects. System is the black box object representing the whole system. Lifeline, this is here. And messages need a directed arrow. Okay, who send the message to whom, right? You need directed arrow. You need direction. And yes, that's all about. I will not go into sequence diagram yet, but we will learn, not go into the white box sequence diagram, but only this black box one with the actor and system. But actually there will be a white box one, but we will learn that after we understand class diagram, because the white box system, the white box sequence diagram, actually, if we have actor and system, actor something, right? What we will say will be like this. And so on. So this is system. Okay, so this is the system sequence diagram. which shows and captures only the interactions between actor and system. On the other hand, even it is the same use case, if it is sequence diagram, not system, the sequence diagram. To be precise, that is why I say white box, but actually that is just my term. Okay, it's not very standard. Okay, if you search, maybe you don't see anything, but it's my term to make you understand. It's the same thing. We have actor A, but instead of just system, user and system interaction, we will have something like UI, product, or sales. Oops. Okay, I need to redraw everything. But anyway, it would be something like this: actor, UI. Oops. We may have sales and even product and so on. So it would be that whether to have UI or not, it depends on how we make a design. Okay, but it assists an actor may activate, make new cell to the UI. What the UI would do is create a new cell object. And then this returns something here. This returns something to the user actor. Then enter item with product ID and quantity, right? This may say that as for a new cell, new item with ID and quantity is passed here. And actually it may need to call something else too. Maybe remove the inventory, update the inventory, update the very many things later on. So this, with this sequence diagram, not the system one, you can see that it will really model and the detail, give a very detailed model of how each use case is represented in terms of execution and message passing among all the objects of the system, starting from actor activating something, performing something, but after actor activating and performing something, what happened in the system? Okay, it's like this object send a message to that and tell the other object to do this and to do that and so on. So you will see the detail of how things work inside the system through sequence diagram. Okay, so questions so far for the sequence diagram part and for the modeling of this. Then next we'll go to the class diagram. I think I can show this first. Okay. Okay, I show this slide first to see the big picture. This is related to object-oriented analysis and design approach, in which all those UML models that we will learn and discuss and make use of. Okay. What we emphasize at the moment was part of what is called analysis. Analysis means to understand, emphasizes on investigation of the requirements rather than a solution. In the object-oriented approach, they really make a very hard line to separate analysis and design, because analysis means to understand the problems, the situation. Design means to propose and to give a solution. So if we talk about the design phase, that is why in the software there is requirement analysis. You see there is the word requirement analysis. There will be another word, system design. So they really make this thing separate, because we want to make sure that when we try to study something, we focus only on the needs, the problem. And then on the design is the phase when you focus on conceptual solution that can answer the needs, the requirements, but separate them so that you focus mainly on requirements first. Then you focus that on those requirements that you understand well already. How would you design a solution? And in this case, it's a software information system, right? Okay. So anyway, that is just to emphasize. And when it is about object-oriented analysis, it's the same thing, but of course it make use of object-oriented approach. And in this approach, of course, with the word object-oriented, right? The main things are objects. The main focus of OO analysis and OO design focus on objects. So that is why describing the objects or the concepts in the problem domain. And then when it is design of the OO approach, it also focusing on objects and how objects collaborate. That is why all those diagrams in UML, you will model a lot of objects and how objects interact with object, actor, object, cell, object, item, object, product, object, many things. They interact with each other by means of objects. Okay, so what we will learn in class diagram. Next is actually used for capturing domain concept of your software. The domain concept means when we use the word domain models, we are focusing on those domain concepts, which mean that the concept within your software requirement. For example, if we are talking about our project, domain concept or conceptual classes would refer to patient as an actor, of course, and also patient as concept in the software, because you need to record information of your patient in your database software system anyway, right? You need to also record doctor, data, right? Represent them in your system, not just the person alone that use the system. You may need to have even medicine, even the treatment, diagnosis. Those could be the concepts that you need to model within your information system, your software. So when we talk about domain model, aka class diagram, we will focus on, we use class diagram to make visual representation of this we call real world, because actually we capture the real world into a software world, right? But it captures patients in the real world into patient objects in the software. It captures information of doctor into object in the software. Why do we need? Because we need to search for doctor, right? You need to search for doctor specialization, doctor availability time, and so on. Then you search from the software, but you represent those doctors' information in the real world, in the software, into the software world. Okay, but not software components. The thing we use these not software components means we don't talk about when you model class diagram, we will not have the class of UI database or something. We just model doctor, patient, the domain concept of your problem, but not the domain of the software. Okay. And okay, this already discussed. This show how all diagrams will we mention would. How can I make this hide? You go and hide. It's behind you. Okay. All right. Here, this show how several of the diagrams we will learn relate with each other and become consistent among each other. So this is number one diagram, as I already mentioned, right? Use case diagram. We start use case diagram very first. And this is the use case description along with each other. That say, if you want to process sale, number one, customer arrive, cashier make new sale in the system, and so on. And this is the system sequence diagram that we just saw, right? Then these are how things relate with each other. Another thing is we need domain model to represent all the classes or objects. Or the concept, representing the concepts of our domain. In which, in this example, is about recording sale, handling point of sale system, right? So we may have the class sale, we may have the class register, product catalog, customer, and so on. And this is through class diagram. Domain concepts need to be captured in the class diagram. And as I already mentioned, in the sequence diagram, this is an example of design model in which you really make a design now of how your system software would work. So it will say that this is a cashier. Cashier would make new sale to the register object. Register create another new sale object, and then enter item, pass this and that parameter, call this and that function or method, and so on. Okay, so this is really the sequence diagram that I mentioned. It tells exactly what happened inside the system, what object pass parameter of call function and method to another object. And actually that is very much corresponding to a code you would write in a program. So that is why this is mostly part of the design step, because you already designed that we will have this class, we have this object with this method and function with this parameter passing and so on. And as I said, everything must be very corresponding. When we have object of the class product catalog here, it means that you need to have in the class diagram product catalog class. And if the product catalog has someone can call this method get specification, in which it may return the specification of a product. You may, in your product catalog class, an object of a product catalog would have the ID, would have the product specification, right? The size, the item, the width, the weight, and very many things, the description. So this method get specification would return the specification of a particular product ID. That's it. Just in case that sometimes you may need to retrieve the price, retrieve the detail of a product. You retrieve it through product catalog class or object. And that means if you say that in your sequence diagram, your product catalog can perform this method or function. In your class diagram, when you make a design, okay, we'll talk in detail of the class diagram soon, but this is to show the corresponding, the alignment. In your class diagram, product catalog must have the method get specification as well. It is like you say that you will use a service of this company, then that company must provide a service. So everything has to be in synchronization and alignment and consistent. Okay, anyway, this is just the big picture to show you how all artifacts inside the UML, artifacts, I mean the diagrams, would need to be consistent. Okay. All right, then I will need to move to back to the slide. I think that's all. Okay. I will move back to the slide about class diagram. Here it is. We were here. Class diagram is part of how we make the domain model. And it's part of the structural model. Remember, the UML is on this side, right? The structural model. This is on the behavioral model. Class diagram is on this side of structural model. Structural model is used for capturing organization of the system in terms of the components. Okay, what components, what structure your software has, your system has. Mostly they are static. They are static models. It just captures the structure of the system design. Sometimes some models are dynamic. Okay. Dynamic means when it is executing, some of the object would be created, some of the object would be destroyed, and so on. Those are represented by object diagram. We are not, object diagram and class diagram are actually very similar. Okay. We will focus on just the class diagram. So the static modeling that, oh, we need to have class patient, class doctor, class medicine, class this and class that. But in real execution, there'll be new patients created, new diagnosis created, and so on. That is the dynamic execution. But static view is just we provide all these classes. Okay. Okay, this is what we already talked about. Domain model is a visual representation of conceptual classes or real-world objects in a domain of interest. In our example, could be the health system, right? We focus on class diagram to show what are the classes in the system and the association between those classes. And as I said, it shows the static structure. We will talk about this terminology soon. But anyone can share with me your understanding whether to you, object versus class, are they the same? In your understanding. But I will correct if your understanding is wrong. And I will support if your understanding is correct. But what is your understanding? Son, you usually be very responsive. Then I would expect an answer from you. No one in the class say anything yet. Do you have anything to share? Who else do I have in the online? Okay, anyway, any idea, do you think object and class, objects and classes, are they the same thing? Answer 1 if you think they are the same. Answer 2 if you think they are different. 1 or 2. I need your hands up now with the answer. Maybe I need you to close the eyes too, so that you don't look around. Oh, what are the majority answer now? Okay, I saw major answers for 2, right? They are not the same, of course. They are not the same, but they are very much related and have certain similarity somehow. Okay, but we will talk about that. We call object-oriented, for example, programming, right? I think if you do object-oriented programming, you know what is object and you know what is class. Anyone write Java programs? Yes? Anyone write some other object-oriented programs and create classes and so on? I think so, right? Not only Java is an object-oriented programming language. Python is also, but whether you use the object-oriented part of Python or not, that's another thing. But then you must already understand, right? What are the differences between classes and objects? Which one is broader? Which one is static and which one is dynamic between class and object? Class is what? Okay. Can I have a class dog and cat? You said animal is a class, dog and cat are objects. But then if I want to model a class dog and a class cat, can I? Yes. Okay, then dog and cat are not objects anymore, become a class now. Okay, objects are instants in the real world. Class are kind of blueprint or template of certain concepts. So if you're talking about the concept or a class of cat and dog, you're not talking about specific instance. You're talking about cats and dogs in general. If I ask you, do you know a cat? I think you have some concept, some conceptual understanding what is a cat, right? How does it look like? What does a cat do? What does a cat eat? What does a cat react to something? Right? You have this conceptual understanding. When I talk about a particular cat, anyone here has a cat or dog? You have here in AIT? At home? At home too. How about you? At home? In your room? How do you adopt it? You bought one or you just found it somewhere? And you adopt it? Okay. So if, what is the name of that cat? Huh? Meow. Okay, good name. Yes, easy and represent a cat really. So that is how a cat would say, right? Meow. Would sing, would say, would, yeah, make sound. So a cat could be a class or concept, but that meow is an object or a real instance, right? So this is how it is different. We talk about the concept, human, person, student. This is a class or concept. But when I talk about you as a particular student, such as Makara, this is an object or an instance, a real instance, the real world instance. A concept does not have a real world representation as a tangible, not tangible, a real world one. It's just kind of template or concept of how things would look like, be like, behave like, or have certain data and so on. Such as student may have date of birth, name, email. This is general for a class student. But when we talk about you as a particular student as an object or instance, you will have specific name, date of birth, email, and so on, right? Which is different from other students' objects. So when we talk about class diagram, we only model general concept representation of these classes in our system. If we talk about the D-Health system, then those classes would represent patients, as I always mention, right? Patient, we should capture name, we should capture date of birth of patient, maybe the weight, the height, because then when we give, why do we need that? When we give medicine, you are prescribed due to based on your age and your weight as well, right? How much milligram of some medicine you need to take and so on. You may need to record we may need to record many things of a patient, right? And so on. So these are patient class. Each patient of the system will be an object. Okay. All right. So that is about, I will skip this, the class and the object. Sometimes to make it very usually common term, we use class. sometimes they use the term object class to say that it's a class of those objects, but I don't think that we have heard or we would have seen this very often. But just to make it very explicit that we are talking about class or class of the object. Okay, so if we mention objects in the object-oriented approach, it would refer to, okay, by definition, an entity, a thing, a real world thing, but could be tangible or intangible, is fine, with well-defined role in your application domain, in your problem, in your software. In object-oriented paradigm, object has state, has behavior, okay, and has characteristics, means certain, actually state means data. It has data through attributes and properties. Okay, these are the states of the object. That's the state, okay, defined here. Objects properties, such as attributes, and the relationship, and the values. When object has attributes, it doesn't have only just the attribute, right? It has the values of those attributes, such as when I said you as student object. Attributes could be name, date of birth. You have the value of your name and the value of your date of birth, right? And so on. Behavior, every object has a behavior. That means what are the things you can do in the software world. Of course, it will represent what we want to capture in the software, such as you may say, oh, student can eat, but we are not interested in modeling the eating behavior in the system, right? We are interested in register a course. If you as a student, if I would be interested in the behavior in a software, right, in the system of a student, I would say register for a course. This is behavior you would do, student would do. Drop a course, add a course, check the grade. These are behaviors of students. I'm not modeling eat, walk, wake up, sleep, okay? No, this is out of the scope of our application, right? All right. Every object has identity. Actually, usually these are done through the programming language itself. That means through the ID. No two objects are the same. And then once we understand these objects and their characteristics, components, behavior, and so on, we could model them as class by grouping objects of the same or similar attributes, similar relationships, similar behaviors together into one class. As I said, each individual of you are one object. I group you all into one class student. Actually, it depends whether you do bottom up or top down. For experienced modeler, we already see, right? Oh, I would say that I model you all as a class student. And of course, I know that each of you will become an object of my class student, right? Something like that. Okay, anyway. So this is another example. The same thing, actually, not another. This, I think if you're familiar with OO approach, right, OO paradigm, when we draw a class diagram, it represents a class. We would make a box with 3 parts. The first on top is the class name. Then the second part of the box is a list of attributes or properties. Then the last part will be a list of operations or methods. So these represent behavior. These represent data or state, right? Behavior means what are the methods, operations, the object of the class could perform and do, such as calculate age, calculate GPA, register a course. The same, using similar notation, we could have a class course model in our example of registration system. A course is a class with course code as property, course title, and credit hours. Then it has operations or function, which is here, enrollment, to return list of all enrolled students, for example. Okay, who belong to this course? It will return a list, something like that. Okay, I think this is, I've finished here. When we talk about this part, look at this example, student. The operations are something like calculate age, calculate GPA, register for a course. For the course class, operation could be enrollment operation. Okay, I would assume, okay, in this example that I made, I would assume this is just to return list of students enrolled in the class. Okay, these are to return age of a student, GPA of a student, and then to add the cost for the student. So when we talk about those operations, a class should have. There are 3 types of class of operations. First is called a constructor, meaning that this operation or method. In OO, we use the word method. Constructor is a method that creates a new instance, such as to create a new course. I would like to develop new course on something. Okay, I create new course. Use operator of operation or method constructor. Maybe a new student enroll in our department. Okay, I would create a new student in the software, right? I cannot create you in the real world. I create you in the software. Yes. Okay, so create a new instance, meaning that this is an object. Okay. Another type of operation is query. Query means to get or retrieve data of a certain object of that class. For example, operation say get, or it could be calculate age, right? Suppose I do have you. I do have a student X. Usually student X dot calculate age. This is the way to retrieve or to call a function in object-oriented, right? Through message dot notation. So if I do have a student X object, I could say student X dot calculate age. I could say student X dot calculate GPA, right? This is a query to return some state, some value, or could be student X dot get name. I make it a new operation, not in the past life, but to return a name, right? I may not know your name somehow. I just want it to return the name to me of this particular student object and so on. Another type of method is update, to make changes, such as to update your name, to update your email, to update anything that belongs to the student object. Class scope operation, this is kind of class method. It applies to the class in general, not to a specific object. Usually if we say that we have a class student, right? It has three parts. When the notation is that when we create an object, sorry. Okay. I need to finish now. Okay. If we have a class student, this is a class, okay. A notation for an object, usually we will use this notation. When it is this, it means it is an object of a class student. This is unnamed. I mean, it's an object that you don't give a name, but you can give a name like as I did before. I call it student X. Then this is student X object. So in the class diagram, you see only this notation. But in the object diagram, it's part of the UML 14 diagrams. You will see all objects will say that it belongs to what. And as I said, this is a dynamic model. Because each student object, you will have such as if the student X is Mr. X, you will have the value. For the class, you don't have value for properties because class is just concept. No instance, no data. You may have what? Date of birth. Then it will have value. 1st of January, something. And so on. This is dynamic. Dynamic because this can change and represent the real world value. At some point of time, you may execute the property get the operation, calculate age. So suppose he was born in 2000, January 1st, January 2000. If we say student X dot calculate age, it should return. I would expect this method to be programmed, right? In the way that it returned to me 23 years old value, right? Something like this. So I can perform and get dynamic data from student from object diagram. And in the class, most of the operation will perform on object, such as calculate age. It is the age of a particular object. But there are some operations that belong to the whole class, such as count. I would say, let's say count student. And then I input the admission year, 2020. I should say year, right? This does not belong to any particular object operation. It's not an operation that will execute on the object itself, such as calculate age. This is for the student object. You will have different age to calculate, right? But count student of a particular admission year. This is not for each of the objects, but it's for the whole class to calculate, to count how many students in total for the whole admission year and something like that. So that is called, that is part of, this is what I said, classical operation. The operation that applies to the class itself, not to specific object. So these are 4 types of operation. So I believe that from here, we could We'll talk about the relationship now, but you could have some idea to apply to your own project. That what are those conceptual classes your project would have? Okay. Would you now model from each use case? If you already model the use case, what would be your use case model? What would be your system sequence diagram that you would draw or represent for your project and so on? Okay, so we continue from this point. But one small thing. This coming Wednesday, I cannot conduct class due to my personal business that I have to cancel the class on Wednesday, this time 10:30 to 12. But what I could do, we can arrange a different time, but then we need to find the time. What time I would be able to arrange? Pardon? Tuesday or Friday? Friday morning, but Tuesday, what time? No. Someone say no. But Tuesday, I don't know. Tuesday means tomorrow. Tuesday, anytime you are free. Tuesday means tomorrow. Do you have other classes on Tuesday? Any one of you having class on Tuesday? What time? 1 o'clock to 1 to 4. But then after 4? Pardon? Evening? You have class from evening. What if I propose that okay, maybe I try to schedule and inform or communicate through the classroom, somehow make a vote or something. And of course, I could have made it a kind of recording lecture so that you can watch and follow the lecture anytime you are free. But of course, I would encourage if you are free at the same time that I'm recording, right? It would be good so that you can have a focused time, concentration time, and ask questions if you have and so on. But otherwise, if the time that we could make up would not be convenient for everyone, then majority, and then those who cannot join the class at the time, then you watch the video. Okay, but that forces you somehow to self-manage. When it comes to watching a video or at your own management, right? That is a thing that I believe it will be not at all for some of you. Never watch until you really need it. But anyway, we will communicate. And yeah, I think you need to have a lunch break now. Okay, so thank you for today. And then I try to schedule another class and let you know as soon as possible. Thank you.